You can use the vertical line test to determine if a graph represents a function. So I have 6 examples here. Let's check out how we can use the vertical line test to determine if each of these graphs represents a function. So in this first example, we have the graph y equals negative x. The vertical line test says that you can draw a bunch of vertical lines straight through the graph, and if any of these vertical lines intersect the graph at more than one spot, then the graph is not a function. So for example, this first vertical line, it only intersects the graph at one spot right here. And this next vertical line only intersects right here, and the next one only intersects the graph once here. So we can see for each of these vertical lines, they're only intersecting the graph, or they're only crossing the graph one time. So because of that, we would say that yes, this graph represents a function. So let's check out example number 2. We have y equals x squared. So again, we can use the vertical line test to draw a bunch of vertical lines through the graph. And if any of these vertical lines cross the graph more than once, then it's not a function. So we can see for each of these vertical lines, they're only crossing the graph at one point. So this vertical line crosses right here, this one crosses right here, this one crosses right here, and so on. Each of these vertical lines is only crossing the graph at one particular point. So we would also say that yes, this graph also represents a function. All right, let's check out number 3. We have x equals y squared. Now, when we use the vertical line test for this one, let's see what happens. So we're drawing vertical lines through the graph at multiple different locations. And we can see that for each of these vertical lines, they're crossing the graph at 2 different points. So this one crosses right here and down here. This next vertical line crosses right here and down here. So because the vertical lines cross the graph at more than one point, we would say no, this graph does not represent a function. And by the way, we say that a relation represents a function if we're able to put in one x value and only get one y value as an output. So like for this example, if we plugged in a 4 for x, the possible y solutions would be -2 and +2. So on the graph over here, let's say this is 4 right here for x. If we plug in a 4 for x, we could get a +2 or we could get a -2. So 2 possible answers. So when one x value corresponds to 2 possible y values, we say that that is not a function. So that's just another way to think about it. Okay, let's check out example number 4. We have the graph y equals x cubed. So we can use the vertical line test to check if this graph represents a function. So when we draw all these vertical lines, we'll see that the vertical lines are only crossing the graph at one point. So right here, right here, right here, they're only crossing the graph at one point. So we would say that yes, this graph represents a function. All right, let's try number 5. We have y equals the absolute value of x. So again, let's try the vertical line test. So we'll draw a bunch of vertical lines, and we will find that each of these lines is only crossing the graph at one point. So this crosses right here, this vertical line crosses it right here, right here, right here. So since each vertical line is only crossing the graph one time each, we would say that yes, this is also a function. Let's check out this very last one. We have x is equal to the absolute value of y. So if we do the vertical line test on this graph, we will find that each of these lines is intersecting the graph at 2 different points. So this first vertical line crosses it right here and down here. This next line crosses it right here and down here. So because the vertical lines cross the graph more than once, we would say, no, this is not a function. So those were just a few examples of how you can use the vertical line test to determine if a graph represents a function.